Welcome. Today we are going to study data preparation. So the first question is how to add an index field using Python. So we are going to import a module that is called as Panda. Then we import the data set under the name bank train by using the read CSV command and specify the file's location. Here we'll specify the file path, that is the location of the file. And as discussed in the previous video, we know read CSV command is in the pandas package. We need to give the name of the package before the command. As we open the pandas package as pd, the full command is pd.readcsv. So to create the index, we first need to find the number of records and column in the data set. Blank train.shape, using .shape after the name of the dataset, will give us the number of rows and columns in the dataset. The first number in the output is the number of records, 26,874. The second is the number of variables. Once we know the number of records, we create a new variable that assigns every record a unique integer. The nested command series and range create a string of numbers whose lower bound is 0 and upper bound is the number of record. Since the series command is contained in the pandas package and we renamed the pandas package pd, we preface this series command with the pd and a period. The result is the code pd.series. Note that the lower bound of the range command is 0 and not 1, as Python begins counting location at 0. We save the series of number as a new variable in the dataset index by assigning the output of pd.series bracket range to the index variable of the bank train dataset using bank train index. To view the dataset with its new variable, we can look at the head of the dataset. Bank train.head, using .head after the name of the dataset will generally output on containing first and last 30 records for every variable in the dataset. So this is the code. As we discussed, we are gonna import pandas as PD. This is the module that we discussed, and then we import matplotlib.pyplot as PLT. Then we entered the location. This is the file path location. Then we did p then we set bank train as equal to pd.readcsv. Whatever I have explained, this is here in the code. You can see dot reset index drop equal to 2 in place equal to true. Then we print. Then here we find dot shape that gives us the rows and columns. That gives the shape of the data frame, and bank train.head display the first few rows of the data frame. Here we have used captions. Here we have used comments. These are the comments. So this is the output of the previous code. As you can see, numbers, age, job. This is the data set that we used, and here are 5 rows and 21 columns. Second question, how to change misleading field values using Python. If you do not open the pandas package or read in the dataset as described in the previous Python section, so we can do it now. We also need to import the numpy package for this section. So we'll do import numpy as np. We need to identify all the records with days since previous value of 999 and replace them with the Python code for missing numbers. NaN. Once the replacement is made, we will save the variable under the days since previous variable name, effectively overriding the previous variable's values. So here we can see bank train days since previous is equal to bank train days since previous. Dot replace, and here we have done this. The code bank train days since previous access the variable days since previous. The command replace finds each instance of 999 in the days since previous variable and replaces it with the value NaN. To save the newly edited variable under its original name, we set the right-handed side equal to the original days since previous variable on the left by reusing the variable name bang train days since previous. To create a histogram of the variable, use the hist command and bang train days since dot plot kind equal to hist. Title equal to histogram of days since previous. Using dot plot after the variable name will make a plot of the variable. We use kind equal to hist to specify that histogram should be made. The title input contained in single quotes creates the title of the histogram. So this is the code. We have imported NumPy as well as pandas. Then matplotlib, we have entered the path of the file. We have done this pd.read. Now as we have to replace 999 with nan as discussed above, we say bank train age equal to bank train age dot replace. So we are replacing the age here. Bank train age dot plot. We are creating a histogram of age. Show the plot plt dot show. So this is the output. This is the histogram of age where we can see the frequency and the age. Question 3. How to re-express categorical field values using Python. So we will replicate the education variable and name it education numeric in preparation for replacing its categorical values with numerical ones. So bank train education numeric equal to bank train education. So this we have replicate the education variable. So the right hand side of the equal sign specifies the education variable. And the equal sign assigns those values to the left hand side. There is currently no variable named education numeric, so one will be created and given to the values of variable education. We need to set up a dictionary specifically for converting the categorical values in the education numeric variable to numeric values. The dictionary is contained in curly brackets. To set up our dictionary, dict_edu is equal to education numeric illiterate 0 basic.4y4 basic.6y6 basic.9y9 high school 12 professional course 12 university degree 16 unknown npnan. Inside the dictionary, we use education numeric to specify the variable which we want to recode, followed by a colon and another set of curly brackets. Within the second set of curly brackets, we specify the recording in the following order: variable's original value, variable's new value. Each specification is separated by a comma. Note that we use Python's value for missing numeric values NaN where necessary. Finally, we tell Python to use the dictionary to replace the variable's values. Bang train dot replace dict_edu in place equal to true. The command replace will replace the values according to the rules in the dictionary. Dict_edu. So this is the code that we discussed above. We used NumPy, we used pandas, and we have written the file path here. We have taken pd.read csv with file path. Now, assuming education is the column that you want to re-express, we take dict_edu equal to, then we take education numeric, and these are the things that we are written in code, and we take unknown as np.nan. Then we replace values in the education column and create a new education numeric column with bank train dot replace dict_edu comma in place true. So the output of this looks like this. Question 4. How to standardize numeric fields using Python? Import the required package first from, from SkyPy import stats. We will standardize the age variable and save it as a new variable age. Bank train age set equal to stats dot bank train age. The z-score function calculates the z value of the given variable. In this case, age written in the code as blank bank train age. As the z-score command is a part of stats package, we write the command as stats dot z-score. We save it a new variable in the dataset age z. So this is how the code looks like. We have imported SciPy import. We have from SciPy import stats. We have imported stats from SciPy. We have imported NumPy. We have pandas as well. Then we have the file path. We have pd.read csv and file path. And then assuming age is the column that we want to standardize, we have taken bank train age z equal to stats.z score bank train age. So now question 5, how to identify outliers using Python. So for this example, we will continue using the age z variable that we created in the previous question 4. We will find out outliers by using the query function, which identifies rows that meet particular condition. Bank train dot query age z should be greater than 3 or age z should be less than -3. The condition we want all returned records to meet is given. Age z should be greater than 3 or age z should be less than -3. In other words, this condition requires each record to either have an age z value greater than 3 or value less than -3. So the or is specified by the character slash the straight line between the two condition. All records which meet the specified condition are returned. In our example, there are 228 records that have age z values greater than 3 or less than -3. We can use this record to create a new data set which is made up only of these values. So this is how we write it. By giving the output of the query command a name, we create a new data set of only outliers which we have called bank train outliers. Let us sort the dataset bank train outliers by its age z variable. So bank train sort equal to bank train dot sort values age z comma ascending equal to false. The sort values command will sort the record in the dataset based on a specified variable. The sort can be ascending or descending. In this example, we want the largest age z value at the top. So we can sort in descending order by specifying ascending equal to false. We can save this sorted data set under its own name, say bank train sort. Finally, let us say we want to report the age and marital status of the 15 people who have the largest age z values. This condition specifies both the number of rows to export 15 and columns to report the variable named age and marital. Bank train sort age, marital dot head n equal to 15. So we have given bank train, we have to sort in age and marital. These are the columns where head equal to, that is number of rows, is equal to 15. We have given it. The double bracket notation given after the dataset name let us specify which column to include. The command will give the top record stopping after n record if n is given. So it will stop after 15. So this is the code. As you can see, from SciPy import stats, NumPy, pandas as usual. We have taken the file path. We have taken bank train is equal to pd.read csv. We have standardized the age, that is bank train age z equal to stats.z score. This is how we standardize the age. We have done it before also. Bank train outliers equal to bank train dot query. This is the condition that we used. And this is that we have to take in descending order. That's why here we have taken it ascending equal to false. We have sort the values here. And now we are display the top 15 rows. To display the top 15 rows, we have taken bank, train, sort, age and marital, where head is equal to, that is number of rows, n equal to 15. So that it will stop after 15. Now what we do is print the result, print top outliers. Now let's see the output. Here is the output. As you can see, there are 15 number of rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 number of rows, and as you can see, column specifies age and marital. That's it. Thank you.